Alright, so this talk is about the why of reactive programming. We'll look at a little RxSwift in here, but mostly I want to get at the concept of why you would bother learning something like this. So first we need to understand what is reactive programming. And one sort of wordy way of describing it would be an API for describing your control flow with declarative behaviors ahead of time prior to asynchronous events firing. And this probably still won't make much sense to people, but it's a hard thing to describe in one sentence without examples. So this is versus imperative programming, where you define logic to run at the time an event fires and you cannot compose events. So think of like delegate calls, where when a delegate is called, you get a little time to run some code, but you can't really compose that together with other delegate calls or other asynchronous events like closures firing. So with reactive programming, we treat all inputs as streams of events with values over time. So an event can happen like a user taps and there's a value there, which might be about the button or the view that was tapped. But we can combine or we can compose, filter, and transform these events. And so this is basically also the observer pattern, where we subscribe to changes as they happen, similar to some other things in Cocoa programming like KVO or subscribing to NS notifications, that sort of thing. This is also data driven. So I want you to think spreadsheet, not calculator. So with a spreadsheet, when you're defining your formula, you might compose a bunch of things together by having different cells with different formulas that have input from previous cells. And you don't like go in and execute a cell and paste in some information, get the result, and then go to another cell and manually paste in the information there and then get that. You don't do that. So you kind of link them all together by referencing other cells as inputs. And so you just change the data at the top and it drives the whole thing. And then you see your final results, whatever they may be. And also similar to a spreadsheet, we can combine and split out different things. So we might have a couple bits of data at the top, and those are driving a whole bunch of different results at the bottom, depending on what we're looking for. This is really not just a utility. While something like RxSwift can be used as a utility, and it's really good for that kind of thing, the main gain is by thinking of this as a whole different mental model of programming. It adds a concrete entity for representing future values. So whereas something like a closure, that's not representing future values. You only know about the value and can reason about it at the time it happens. This lets you represent that ahead of time. Once you understand this style of programming, it's much easier to reason about complex control flow through your class. It's much easier to coordinate concurrent asynchronous tasks. It does help eliminate a whole class of bugs, and that's not to say it's a silver bullet or there aren't other bugs that come along with reactive programming, but it does eliminate a whole class of bugs that we'll talk about later. And Rx itself is consistent across platforms or languages under the Reactive X kind of umbrella. So Rx Swift, Rx Java, Rx Ruby, a bunch of different languages, they all have the exact same pattern. And while some operators might be named slightly differently, they all basically can do the same thing. See, there are just some downsides. There is a steep learning curve to mastering reactive programming, although I think the getting up to speed initially is maybe not as hard as some people may think. Really mastering it takes quite a while. The tooling is sometimes awkward for debugging. Xcode has its own issues of its own, but once you add in something like reactive programming where it's bouncing through a lot of different internal classes whenever an event happens. So you might look at a stack trace and you'll see a lot of stuff that isn't your code in the stack trace, and it can be a little hard to weed through. But they do provide some help for that can make it actually not too bad to debug as well. UIKit and other Apple frameworks are imperative. And so you are sort of bridging worlds here where you're developing reactive and then you are um, working with against imperative libraries. And there are some tools in RX Swift, actually in a sort of an addendum called RX Cocoa that does some bridging there that makes that a lot easier to deal with. Okay, so your app at any given moment is a result of all the events or inputs that have occurred up until that point in time. This is sort of our leaping off point for reactive programming and the why of it. Some of these events or inputs also have values, and we'll get into that more in a second. But really, what we're doing is taking inputs and turning them into outputs, with what we present on the screen. And so, what events are we talking about? Well, everything: user gestures, text entry, network responses, push notifications, location changes. System frameworks sending data from the sensors like GPS or whatever. And these are all from very different sources, but basically it's the same thing. A thing has happened, and here's some data about it, or maybe there was a failure from a network response. And so like with a tap, that might be, here was a tap, and here was the button that's tapped, or here's a text, here was a change, and here's the new text that changed. All of these are basically the same thing, even though a lot of times they have totally different APIs. So let's talk about control flow. And this is really the thing we spend most of our time doing. It is how do you reason about your input and turn it into output? And usually it's not just one input, it's several inputs or a dozen inputs in a class, and we have to say, okay, when this happens, check this, and when that and if that's true, then go this direction. Otherwise, go that direction. And often it's not simple. It's not like we just initialize a struct and it's calculated one time and that's done. We have to deal with all these asynchronous events happening and control the flow of logic through our classes when those happen. So this is basically what we do all the time. So let's look at the imperative tools for asynchronous events. So this is delegate method success event. So this is an event that happened. A user tapped a cell and there's some data about it. So I just want to call these out. These are events that happened. And you'll notice that these are inputs to our classes. Like your class is already instantiated here, and this delegate method is firing. And now, so we're going to run some more logic. So this is an input into the control flow of your class. Here's a delegate method failure event. It failed finding a location here. And this has some data as well, and an error. Here's a different type of event. This is an API that we're calling with a closure, a completion handler. And so this one could be a success event or it could be an error event. If it's a success event, then it's just showing that there's no data with it. It's just showing that it succeeded. And here's some other types of events, target action types or IB action, that a user tapped to change club. And that's an event happening. They tapped this button. Or the target action below, we're adding this target action for an event happening, a UI control event. They're even called events there for whenever the text changes. And again, this is inputs into your control flow, into your class, and they're spread all over your file. So these are the existing tools in our tool belt, right? Delegate methods, APIs with completion closures, notifications, KVO, Grand Central Dispatch, UI control events, and there are others, right? These are all asynchronous methods. They're asynchronous tools for handling asynchronous events. So basically all the same thing. An event happened and we need to handle it and work it into our logic. But these all have entirely different APIs. None of these give us the ability to define ahead of time in a declarative fashion how these events relate together. Now, what do I mean by imperative handling of events here? So let's look at a delegate method here. Username text did change. And what we want to do is we want to affect this register button being enabled. But the problem is the only thing coming into this event is the text of the username. if you look at the logic, password text is involved in this logic, and there's some event probably that has set the password text, but we don't know what that event is in here without reaching outside of our context, without reaching outside of this method to some stored value. So we only know about the one event that happened, and then we have to build up our own context with properties that we've stored stuff on to have enough information to do our objective of updating that register button enabled. So I want to call out that there are relationships between these events. They are informally defined and manually maintained. And what I mean by that is we have two events happening here, both delegate methods, username text did change and password text did change. Both of these update the state of the register button enabled, but they rely on data from the other event. And so we're combining data from the two different events there. And that means there's a relationship here between these events. The username text is relying on data from the password text event to determine its logic for the register button enabled. But there's no compiler helping us here. If we introduce another event that also impacts the register button enabled, we have to remember to come update it in all these different spots ourselves. And there's no help from the compiler saying, hey, you missed this spot, you need to update it here as well. In addition, you could also have another place that updates one of those properties, like password text could also get updated from maybe a reset form function. And then you need to remember to also run the register button enabled logic there as well. So there is a relationship between these events. They rely on data from each other, but there's no way to codify that and to get help from the compiler if you need to change any of those relationships or introduce new relationships or remove relationships. You just have to remember this all yourself. So what relationships can we formally define with the tools provided? If that's an informal one, what's a formal one? Well, we can use blocks, operations, and Grand Central Dispatch to do a couple things. We can serialize asynchronous tasks to create a formal relationship. And we can notify on completion of concurrent asynchronous tasks. So we'll look at what I mean by that. So we can serialize with blocks, and we've all seen a lot of this where it just starts cascading off to the right-hand side of your screen. There is a formal relationship here, though. So each inner asynchronous event has a formal relationship to the ones before it in that it knows those have completed, and it also knows the data of those. So there's a formal relationship there. The compiler is helping us. If I inserted another asynchronous event inside my happy path here, I would automatically have access to the things before it. And I can't just remove one of these inner asynchronous events because it's happy path, the asynchronous event internal to that, is using the result of that. So the compiler is going to say, hey, this result is gone. You removed this closure. So there's a formal relationship here. It's not particularly pretty, but there is. And you'll also notice that there's no easy way to cancel internal calls if the top one starts again. The error handling is spread out all over the place. And your happy path is in the middle of the code. We can do the same thing with operations. Operation queues are fairly powerful, and here's one reason why, is that we can add dependencies so we know when this thing isn't going to start until the previous one has completed. And so that's a formal relationship there. You can even, with the non-block type of operations, you can even reach into dependency operations and determine what the result was there. You can access a property on there. Another formal relationship we can create between a couple different asynchronous events is to find out when they have all completed. So here we have a couple different asynchronous calls firing off, something to get the closest club and something to get this photo subscription status. And maybe we want to do something when both of those have completed, but not just when one of them is completed. Well, one mechanism we have to do that is Grand Central Dispatch's group notify. We can start a group before either of those before we start either of those asynchronous events with group.enter, and then we can group.leave and the closures, the completion handlers for both of those asynchronous events. And then we have inside of our group.notify closure that we've set up is what to do when everything has completed. We can call our handle update function. Couple things here though. Our group.notify closure doesn't get any kind of results from the different asynchronous events that it's tracking. So we have to store those in state somewhere to get access to that data to have any real value out of knowing that those completed. And also error handling is sort of a question mark here. If one of those errors, what happens? Does the other one continue? Is there any, so that's also a question mark here. And then what if we want to get multiple updates? The group.notify here is only really going to help us one time. It's going to let us know when both of these events complete the first time. But what if we want to know subsequently when either of those start changing again? Like if the user moves and they get a new closest club, and now we want, okay, what's the latest set of club and subscription status? Well, this doesn't really help us with that either. We would have to roll our own, and then you get back into really complicated state management. This can also be achieved with operation queues. And that's pretty much it. That's all. That's the whole gamut of formal relationships we can create between events in imperative code in Swift. So if only we had some sort of API where we could get a reference to this asynchronous thing. We want to get the closest club, and we're going to grab a reference to that asynchronous event. And then we're going to get the photo subscription status, but we're going to get a reference to that asynchronous event. So neither of these have completed yet. And then we have some sort of function that say combine the result of these things whenever they complete. And then we can either call an update handler or an error handler. And this could let us even get more updates than just these things firing once if we want. And it unifies the error handling between the two and makes that pretty clear. So how are we currently solving for this? We're making this work in imperative code. So, well, let's look at the events coming in. We have multiple events that we've been talking about here. Each event has a bit of data, but that event data alone isn't enough to affect the output that it's trying to generate here, whether or not the register button is enabled. And so we are reaching out to state. Each event is storing its data in state, which other events potentially are then in the future looking at and to build up enough context to inform whether or not the register button should be enabled. And this is actually problematic. Humans are really bad at this kind of thing, at tracking all this state and making sure it gets updated in all the right spots. It's highly error prone. For instance, if we introduce a new event into the mix here, name field text did change, and that's affecting the register button enabled. We've got the logic correct there. It looks at the username text property and the password text property, but there were two spots that were already calling that register button enabled logic, and we forgot to add in the additional state check there. And then we added a new reset form tapped function, or this was an existing one, that we now also forgot to update that to reset the name field text state. And also, it doesn't run the register button enabled logic. So this is a bunch of stuff that we just have to track in our brains. The computer can't help us out, the compiler can't help us out and say, hey, you've defined these relationships that ultimately affect this output, the register button enabled. And if you introduce one, I can tell you, I can make sure that you've updated it in all the right spots. We don't have anything like that. This is all just, you have to look at a file and grok the whole file, read the whole file, understand the flow, and then make sure the state is updated in all the right spots. And again, our control flow, we're coming into this flow from any number of different spots. So I have to make sure the same thing happens when I come into username text did change. That happens when I come into password text did change. I got to make sure through all those different entry points into our logic that it ultimately updates the register button correctly. So state is pretty evil. Not only are we bad at remembering to track it everywhere, every time we add another property here to track some state, even if these are only Booleans, we're exponentially increasing the number of combinations that we have to reason about. And So, and this doesn't even include something like an enum or something else where there's multiple values that we're going to deal with. And without creating explicit relationships, you're going to have to deal with any combination of these at any point in time. Okay, so we say we can make that code better. We've all done this. It's a smart way to handle this. You extract the update logic into one spot, so you're not remembering to update it in a whole bunch of places. Your control flow is still all over the place. Where you enter your class, all these different delegate methods is where your logic through this flow can start. And anytime you change one of these states, you still have to remember to add the update function there. Like if there was some other area where I update the username text outside of that particular event, I also have to remember to add the update login button status there. There's no formal relationship still, so that's not automatically going to happen for me. All right, so we have some tools. Maybe we can make that a little better. What if we pull out the update login button status and put it in did set on each of the states that we change, so that now whenever we add some other place where that state is updated, we don't have to remember to also call the update login button status there. It seems like a potential win. Less that we have to track in our heads, so the computer is actually helping us out a little bit there, tracking that. There's still some problems though, like in the reset form button or the reset form tapped function. That update login button status is getting called 3 times. Maybe we don't want that, or that's not performant. And the other problem is with these overridden setters, that code's kind of like hidden. It's a little bit discrete and might not be noticed to others that are editing your class, and they think there's just this property they can change, and they're not expecting something like the update login button status to fire. So what if we want to check the username to see if it's available by using a web request? Well, we don't want to be doing that every time one of the other states change. We don't want to make a web request anytime all of the other things change that have nothing to do with the username. And we certainly don't want it happening 3 times when the reset form fires. So let's move that logic. We could take that web check and we put that inside the did set for the username text. And then we have that update yet more state, something called username valid now, that we are checking when that responds. And then we'll have the username valid did set call the update login button status. So this code is getting pretty complicated at this point for something fairly simple, and we're not even actually done yet. This code can't even fit on one slide. Things that we still haven't addressed include the expensive username check isn't buffered at all, so if someone's there typing away, every time they're making a change, we're firing off this expensive API call. It's also not canceled when a new one starts, so you could have order of operation errors when you fire off a request to check a username, they update it, it fires off another request. The most recent one goes quicker for whatever reason and comes back as invalid. But the older one comes back and then says valid and cancels out the correct status. And then you have an issue with your UI. Username valid is potentially set on a background thread. We haven't really handled anything with that. Username valid is not cleared when the reset form is cleared. We didn't add that in there. So that's another thing we forgot to track state-wise. And updates still run 3 times when we tap the reset button. We haven't fixed that. And maybe most of all, we have to read this whole file to understand the flow and relationships, the control flow. Because there's so many entry points, all those delegate methods, the logic could be starting from there. And so I have to understand that, okay, my flow could start here, and let's follow it through and see where all the things it updates. I'll have to look at this somewhat invisible did set operation to see that this thing happens. It's pretty hard to grok, especially if it's a larger file. So what if I only want to run the code when all states change and aren't empty, not just when one changes? Or what if I want to cancel an expensive update operation when one of these state changes? And what if I want to buffer how often an update is called? Or what if I want to ensure update is called on the right thread? Well, so let's look at the reactive way of doing this. We're going to use a unified API that represents future events that we can reason about ahead of time. We're going to formalize the relationship between our events. And we're going to get a standard set of operators to compose and transform this event data over time. So what are some of the benefits that we're going to reap here? We're going to get a singular path for control flow through our class, much like auto layout, where we're declaring the layout ahead of time. We're going to declare our logic and our relationship between the different events ahead of time at the top of our file, and we can see the exact flow instead of having to bounce around and grok the whole file before we can figure that out. We're going to get a unified API for dealing with asynchronous control flow. So we're not going to have to deal with the different APIs of delegates and blocks and KBO and notifications and all these different mechanisms that we usually need to combine. We're going to instead just have one. And it's going to make it trivial to combine concurrent asynchronous events. Something that's actually kind of painful to do in Cocoa. We're going to get easier thread safety control to make sure we're calling the right functions on the right threads. And we get that event data driven design. So like I said before, kind of like auto layout, we're going to set up things ahead of time. We're going to declare, okay, here's all these events relate together. And when those events fire, then it's just going to flow through our declarative logic, and the data is going to drive what happens. So I talked about one unified API to represent all asynchronous control events. In RxSwift, that's called an observable. In other libraries, it's called a signal, and probably other things as well. And you can think of it, it's a concrete reference to a stream of events that are going to happen over time. We subscribe to the stream, or to the observable, and you get the events, and you react to them. You react accordingly. It's sort of like a future or a promise, but on steroids. It's a lot more powerful. An observable can send 3 kinds of events to its subscribers. A next event which says, this thing happened, and here's its value. Sometimes you might not care about the value, you just want to know that the event happened. And a completed event, which means, this observable is done. It's not going to send out any more values. Then also an error event, which also means the observable is done, but in fact it actually errored, and here's the error data. An observable can send an unlimited number of next events. It's not limited to just one, like a future or promise. So over time, this observable might just send a lot of different values as whatever thing that we're observing is changing. If it sends a single complete or error event, the stream's going to terminate. That's you know that observable is not going to send any more values after that. Everything is a stream. Literally all events with their values can be turned into an observable. A button being tapped, might be tapped a whole bunch of times, so there's a bunch of next events. A network request is usually just going to have one next event. Here's the data, the response from the API, and then the stream is complete. You could have one for your cart contents changing. Every time the items in the cart changes, we send a next event and say, here's the list of items, and someone else can subscribe to that and say, okay, is any of those items showing currently on the screen? If they are, then maybe I'll update a number and cart badge on that cell. The way we work with these streams is with operators. There's a lot of standard operators that you might recognize some of them from functional programming, and they're very similar to their counterparts there, almost the exact same. And these let us deal with the events that these observables are sending. There are dozens of built-in operators, and the open source community has created hundreds more. Most of these are chainable, so you can chain them together. That's what you'll commonly see with an observable chain, that someone is piping these basically through each other. And it's really easy to create your own as well. So let's do a reactive take on the example we were working on earlier, where we wanted to update the register button when certain criteria were met from the inputs in the form. So I'm going to create an observable here in a lazy variable. You can see, so think of this declarative code. Remember, we're kind of declaring this stuff ahead of time, largely ahead of time, not when events are happening. I'm not in a delegate call here. This is all being described to the compiler ahead of time. So I'm going to use the combine latest function on the observable, and I'm going to combine three observables. You see a little bit of the RX Cocoa going on here that bridges some of the UIKit imperative world to us. The .rx.text is going to pull off an observable off each of these text fields, and that observable is going to send either a next event with a value, an error event with an error, or a completed event. And the values it's going to be sending with its next events are going to be the text that changed in the field. And so I'm saying, hey, just combine these three things whenever one of these asynchronous events happens, and pass the values, all the values into this function. I'm going to evaluate the function here, and I'm going to give it some logic, and I'm going to return a Boolean. So my observable that I'm creating, I'm going to combine all these together. These are text observables, string observables, and I'm going to combine them, and I'm going to return a Boolean value. So you can see I'm transforming the data. The data is flowing in, the text is changing, I'm transforming it, and I'm outputting something else. So think of it as a node where you've got an in and an out, and you're connecting all these nodes together in a chain. So this is really easy. I've created a formal relationship between all these events. So the compiler is going to help me if I ever want to add another event in the future. I'm going to add my event into my combine latest right here. It's going to make me add the argument, and I'm going to have to evaluate it below. And there's no other way to send a value to this register-enabled observable. No one else can just come in and say, okay, whenever this button's tapped, we're going to say register is enabled. You can't do that. It has to run through this. So your control flow is all in one spot. So we still need to add the reset form. So we got a little bit more code now. We've taken what we previously had in the register enabled observable, and we moved it into a form valid observable instead. We just basically renamed it, the part at the top. And the other thing we introduced at the bottom is we're going to merge two observables. One is the form valid, which was previously a register enabled. So now we're going to merge that. That's going to send a true or false whenever one of those text values changes. And then we're also going to watch the reset form button. And again, we're pulling an RX Cocoa observable off of that. We're going to pull off a tap. And we're just going to map that. We're going to change that tap, which might return a UI button. We're going to just return false. We're going to change that to a Boolean so that it matches our other observable, our form valid observable. They're sending the same sort of thing. So now I'm going to merge those together. And so when either one of those sends a value, now my registered enable observable is going to send that out as its value. So that's real simple here. You see the control flow. You kind of see my node above of my form valid node, and I'm combining it with another node, this reset form button observable, into a new node. So let's look at the final solution here in the reactive way. We're going to add the expensive username check with the API call back in and see how that complicates our reactive code. So you can see we're adding another observable here, another node into our node chain, and we're still doing this at the top of our file. We're describing our different nodes and then combining them together. So this username valid observable, we're going to watch the username text field and pull an observable off of that, the rx.text. So that's going to give us an observable that sends a new string value anytime the text changes in our text field. Well, we don't really want to be firing this network operation anytime the text changes. If they type BOB, that's going to fire 3 times, and we don't really want 3 network calls there. So we're going to use an operator here, and you're going to start seeing us chain some operators off of an observable. And this is a very common thing, an observable chain. And it lets us manipulate the data or filter the data. And so throttle, we're going to say, well, let's throttle this for 3 seconds. If the user types something and then doesn't type anything for 3 seconds, then we'll let the value go through. And if they type a bunch of things, like they type BOB, well, we're not going to send B, and then we're not going to send BO. We're going to send BOB after the 3 seconds have completed. And it doesn't, so that's not manipulating the value at all. It's not transforming it, but it is filtering it. It's filtering out some events. Some next events are happening, and it's not sending them along until 3 seconds goes by. And so in imperative code, that would actually take a fair amount of code and a lot of work and definitely some state. But here, the state is being handled internally in this operator for us. So we don't have to do that. It's really easy to just throw this operator onto an observable. The next operator we're going to use here is distinct until changed. And so what that means is it's another kind of filtering operator. It's not going to transform the value at all, but it's going to look at the new next value coming in, and it's going to store the last value that it was sent in state internally. And it's going to compare them and say, hey, is this the same as the last value that was sent along? And if it is, then I'm not going to forward it. I'm going to filter it out, that event. So if the user types BOB and that comes through, and then they type BOBS, and then delete it and go back and they just do BOB again, so the throttle waits 3 seconds. Events have fired, so the throttle says, okay, it's been 3 seconds. It sends Bob along again. Distinct until change goes, hey, nope, that's the same thing as the last time you sent it, and so I'm not going to send that through. And then we get to flat map latest, which is probably the most scary looking code on here. But once you wrap your head around it, it's actually pretty straightforward. So much like functional programming, what flat map does is it knows how to unwrap an inner observable and send its events along as if it were its own. So in functional programming, if I'm using flat map over a bunch of arrays, when I return an array inside the flat map, it actually flattens that out and combines it with all the other arrays, so it just returns one big array of all the values from the different arrays. So same concept here with an observable. It's expecting me to return an observable inside this closure, and then it's going to subscribe to that observable internally in the guts of flat map. And when events are sent along, it's going to forward those along as if it were its own. And you can go look at the code and see this is exactly what it's doing. It sets up a subscription, much the way we would do an observable, and it sends the values along. So what we're going to do here is check if the string is empty. If it is empty, we're just going to return observable false. And this is a way of just sending an observable right away with one value. And so that's going to return false, and that the flat map is going to unwrap that observable and send false along as its own. If the string isn't empty, then we're going to use this check username API call, which is going to return an observable. We're going to skip the take until for now. We're going to use a retry operator on that observable so that if the check username API sends an error, like a timeout, internally that observable is built to send along an error in the case of a timeout in this API. And we're going to say, well, let's retry this 3 times. So we're going to basically recreate and fire that observable 3 more times, or 2 more times at least, and until it lets the error go through. And so that's all it takes to retry this API call 3 times, is that simple little operator. And if it still errors after that amount of time, then it's going to fall through to the next operator. And the next one is my error handling. In this case, I just want to catch the error, and I don't want my overall username valid observable to fail at this point, because then it's done. That it can't send any more values. So if the user moves to somewhere where the network is now online, I still want this form to work. So I'm just going to catch the error here and return false. So I'm just going to let that username valid send along false. I might do some more robust error handling if I was really building this, but this is good enough for now. So that flat map now is going to get true or false from that internal observable that's being returned. It's gonna subscribe to that and forward along the values. So now those are the values being sent out of the top of my username valid observable, or at the bottom of it, I guess, if it's this chain. And then finally, you're going to see the observe on operator. And all this is making sure we're on the right thread. So an API call, this API call might be coming back on a background thread. We don't really want UI operations happening off of a background thread. So for any subscribers that are watching this observable, we want to make sure things are happening on the main thread. So we're going to observe it on this main scheduler, which is basically just internals for how RxSwift does the thread management. Okay, so now I have my username valid observable, which is watching that text field and making API calls and returning and sending along true or false as a next event whenever it determines what the status is. I want to combine that into my form valid observable. And so it's as simple as swapping out the username text field Rx text observable that I previously had in there, which was just watching the text field. Now instead I'm going to pull in my custom observable I made up there. And I'm going to combine the result of that with the other text fields. And my logic is still extremely simple there. Username valid. I know I'm getting a true or false from that observable. So it's going to combine the events from all of these. And when that's valid, form valid is going to send out a true. And then that is still merged into my register enabled observable at the bottom. So I'm just chaining these all together. Events are happening, I'm transforming, I'm filtering values, and then I'm combining and composing them together. So there is one last step, and that is to hook up our register enabled observable to something. We've been creating our observable chain here and defining how it flows through that chain when different events happen and transforming the values and filtering them, but we haven't actually subscribed anything to the result of that yet. So that's what we're going to do here, and we're going to do the most simple version, which is using a binding. RxCocoa exposes some bindings on a lot of UI controls that enable us to bind them directly to an observable if it's sending the right value type along. So we're going to, our registered enabled observable, which is sending a Boolean, we're going to create a subscription for the register button to that. So the register button, we're going to subscribe the is enabled property directly to the changes coming from that register enabled observable. So anytime it sends along a value, that's just going to automatically get updated, and our UI is going to automatically be updated. We're creating a direct connection from our event handling to the button enabled status. So our events are actually driving our UI, just filtering through some logic and then driving our UI. You can also do a custom subscription. So if it isn't as simple in your UI as that simple binding, you can also just create a custom closure. And we're going to use the onNext closure here and create a subscription. And we're going to update the button the same way we were doing previously, except a little more manually now. And we're also going to update some register label text to say, yeah, you can submit the form, or you need to do more to complete the form before you can submit. And so that completes our example here. You've seen how we look at all the events coming in, different text fields changing, and then also a network response that we combined into our observable chain. We explained all our logic and how these events relate together. We didn't have to add in any fragile state that could be messed with later on by someone else. It's easy to add in another event if we need to. We know right in the chain where we need to do it, and we don't have to worry about remembering to call our update UI method or anything like that. And then the data, and then we create a subscription here and do our output, our side effect at the end in functional terms. And so our data, our events come in and filter through, and they update our UI at the end. And that's the gist of reactive programming. We've described all this ahead of time declaratively, kind of at the top of our file, with creating properties as our sort of nodes in our chain. And then maybe in the initializer of our view controller here is where we did the subscription to update our UI. So this is all basically defined ahead of time, just like auto layout or like a spreadsheet. So we're not doing a lot of manual work all throughout the class, and there's not a lot of entry points into my class. There's one. So that's the idea behind reactive programming.